The given question by the method of this article determine the rectangular and polar radii of gyration of the shaded area about the axis of zone. So here is a by 2 and a zone. So we find the gyration radius of gyration. So first we draw the curve from radius r to a dr small element, and here with angle d phi, and small element is dr, so we can write the area d equals to r dr d phi. From the polar coordinates you may practice of the polar coordinates, after that you can got the result. Okay, then we can go area. So firstly integration dA, so r dr d phi, but here we want to do multiple integrations because here two variables dr and d phi. So first we consider multiple integration a by 2 to a and r dr, then after the limit of the d phi, so 0 to pi, because here starting point is 0 and the 180 degree from the whole sector. So here we want to integration the a by 2a and d phi. So after the integration we got the value a square by a by 2 and here a square by 8, and d phi is 0 to pi. Then after the calculating value we got the value pi into 3 square by 8. Then now we find the ix, the moment of inertia about x-axis. So ix is y square dA when you go to ix. So we know the simply result y square dA. So where y square dA is r dr d phi. So y square into r dr d phi, or in polar coordinate we simply know y is r cos phi. When you go in not polar coordinate, actually when got the area small element dA, so we can simply write r equals to x, y equals to r cos phi, and where x also similarly we can write x equals to r sin phi. After that we put the value here, so y equals to r cos square phi, and when put the value integration r square cos square phi into r dr into d phi, because r square y equals to r cos phi simply implies, because but here is two variables, so we do the double integration. So r cos square phi r dr and d phi. So value of the cos is initial value 0 and final value pi, and radius also a by 2 to a. So simply write the rq dr, so cos square phi and d phi, and go to a by 2 to a and 0 to pi rq into dr. So 0 to pi r4, and simply calculate this and we got the value. After calculating we simply use simple trigonometric and integration, then we got 15a4 pi by 128. Now we calculating for y-axis, so simply write x square dm, because in y-axis we calculate the integration of with respect to x and area, distance square and into area. So we simply displacement d equals to r dr d phi, and here the simply put the limit a by 2 a and 0 to pi. For d phi is 0 to pi and here is dr simply a by 2 to a. So simply write and x on r sin phi simply put here. After simplifying and do more calculation and got the value, same value 15a4 by pi 128. Then we can add both inertia, then we got the moment of inertia about 0.0. So we can do the calculation, and after putting the values we add to moment of inertia about x and about y. So we do calculation, then we got 2 into 15 f4 pi by 128. After calculating the all values, we got 15 f4 by 64. Then here the space, we write 15 f4, so we can write here due to space, so IO equals to 15 a4 pi by 64. Now we know, so I equals to k equals to root of I by a. So we put the values IO and get the calculation, because before we find the area, so divided by and got the value.